Welcome to Mimi's Math Channel. Today I'm going to do a quiz review over matrices. For example 1, I'm given this matrix and I'm asked to give the dimensions of A, which is the name of the matrix. And when you're trying to determine the size or the dimensions of a matrix, you want to start by counting your rows. Rows go across, so I have 3. And then you want to count your columns, which go up and down. So when I ask you to give your dimensions, you're going to write the rows first. So it's going to be a 3 by 4. For your next one, it's asking you what is A, which is your matrix, and then it's asking for row 2 and the column 4. Where does 2 and 4 meet? -3. Example 2, it says use the matrices below to answer the following questions. So I'm going to be asked to find 1/2 of matrix C, and since they're next to each other without an operation in between, it's understood to mean to multiply. This fraction is known as a scalar, and with this scalar, I am multiplying each element by distributing, and that will give me my final answer. Okay, so now I'm asked to take A and then subtract B from it. So I'm going to go to A and B, and I know that my rule for adding and subtraction says that both of the matrices have to be the same dimension. So I count and I see that there's 3 rows by 2 columns, and the same for B, 3 by 2. So yes, I can actually add or subtract these. This one says subtract, so I have to be careful. Whatever follows that subtraction sign has to change because this is really -1 distributed to each element inside of matrix B. So it will look like this. I'm just going to change each sign inside of matrix B, and then I'm going to go ahead and change this to a plus sign. And now I can just go ahead and add each element that's in the same position. So 0 and 11, 7, -5, 4, 7, 1, -8, -3, 0, 5, and -2. So what I will notice when I'm adding and subtracting is because I have to have the same dimensions of my matrices, my answer will be the same dimension as well. So it's still going to be a 3 by 2. For D squared, it's asking me to count the rows because when I'm multiplying this time, I don't have to have the same dimensions, but I do have to have the middle numbers of the 2 matrices have to be the same. And then whatever is left on the outside will be the answer's dimension. So what that looks like for D, that's going to be 2 rows by 3 columns, but D squared means to multiply it times itself, times another 2 times 3. Well, I see the middle numbers are not the same, so I cannot even multiply this. But if they were the same, the numbers that were left over would be the dimensions of my answer. But in this case, they're not the same, so my answer is not possible. All right, going on to example 3. This time I'm asked to solve for x in the equations below. So if I look here, I'm going to have to move the 2b over, just like you would do a regular algebra problem, and leave x on the side by itself. Once I subtract 2b, I'm going to have x is equal to a minus 2b. And now I'm just going to substitute in. I notice I have a minus sign here, so I'm going to change every sign of the element that follows it, and then I'm going to go back and change this to a plus sign. So now I'm going to take this scalar and distribute it to every element that's inside of matrix B. So now I can just go ahead and add, and this is my final answer. What I'm going to do now is I'm trying to get x by itself, so I still have to move the b over. So I'm just going to bring down the -1/4 x. When I move over the 3/2, I'm going to change the sign, so that's -3/2 b. And now what I want to do is I want to get rid of -1/4. Anytime you have a fraction, you just multiply both sides by the reciprocal. What you do to one side, you do to the other. Now really, -4/1, you can just say -4. But on the right-hand side, this is an expression, so I'm going to have to take -4 and distribute it to both -a as well as to the b term. And once I do that, I see that x is now on the side by itself. However, I now have a -4 times -a, which is a +4a. And then I'm going to have -3 times -4, which is 12, and that's divided by 2, which gives me a +6. And then I have b. All right, so I just substituted in for the a and the b, and I have the scalars 4 and 6 on the outside. Once I distribute the 4 to each element for a and then the 6 for each element of b, I actually will add each element to get the result. Now for part 4, it says use the following matrix to answer the following question. So I'm using F this time. DET stands for determinant, and I want to use the formula which tells me to take AD and then I'm going to subtract BC. So AD in this example is going to be 4 times 5, which is 20, minus, and then B times C is negative 14. And we know that when you have two minus signs next to each other, that turns into a positive. 20 plus 14 is going to be 34. We need that for the next problem, which says to find F inverse. And in order to do that, we're going to use the formula 1 over your determinant, which is 34. And now this time, you have to switch your D and your A. So this is the D position and this is the A. So I'm going to swap those. And so 5 is going to go first and 4 is going to go last. And then it also tells me in the inverse formula to change the sign of B and C. So since this is positive 7, it now becomes a negative 7. And since this is negative 2, this now becomes a positive 2. Once I set it up like this, I'm just going to use this as a scalar and distribute it accordingly. All right, so that is the inverse that I came up with. And then the last example is asking for me to verify that F and F inverse, are they actually inverses of each other? So what you would have to do is substitute in for F. You want to multiply that by the inverse. All right, when we are multiplying, we're going to take the first row of the first matrix and multiply it times the first column of the second matrix. Then we're going to take that same first row of the first matrix and multiply it times the second column of the second matrix. Once you're finished with both columns, you're going to go down to the second row of the first matrix and multiply it times the first column of the second matrix, and then go back and take the second row of the first matrix and multiply it times the second column of the second matrix. It might be helpful if you set up your matrix knowing that the size of the first one is 2 rows by 2 columns, and then the size of the second one is also 2 by 2. So since the middles are the same, that means what's left over is going to be the dimension of my answer, which is going to be a 2 by 2. So it might be helpful to go ahead and write 2 rows and 2 columns, and then you can fill in your blanks. Once I multiply this out, I'm going to take the first element of the first matrix and multiplying it times the first element of the second one. And then I'm going to take that second element of the first matrix and multiply it times the second element in the column of the second matrix. Whatever that answer is, I am going to add it to the first answer that I had. So 10/17 plus 7/17 is 1. Now I'm going to go on to the next one, and I'm doing the same thing, and I will just populate the answers for you. So 4 times negative 7 over 34, simplify that and show your work, and then add that to 7 times 2 over 17. All right, because the answer came out as 1001, this is known as your identity matrix for a 2 by 2. So that does verify that yes, they are inverses of each other. Thank you for watching. Please remember to like and subscribe. Have an awesome day.